Welcome to Chapter 10, the Muscular System. In Chapter 9, we focused on the different types of muscle tissue, the physiology of muscle tissue, and how it relates to muscle contraction. In Chapter 10, we break it up into 4 parts, and the majority of Chapter 10 will focus on specific muscles in the human body. Part 1, however, we will address some new terms as they relate to functional groups of muscles. We will talk about actions again. We will see how we name certain skeletal muscles. Then we will move into the arrangement of fascicles, and we will finish up with different lever systems. We will begin this lecture by saying that muscles only pull on bones or skin. They never push those structures away. So even though sometimes you feel like you're pushing, for example, in a push-up, that is actually the result of certain muscles pulling on bones to allow you to feel like you are pushing. Something else we need to address is the fact that whatever a muscle group does, there is another group that undoes that action. Some groups that oppose each other that you might be familiar with include the biceps and the triceps, or the quadriceps and the hamstrings. On this slide, and also included on the next slide, you will see some bolded terms. You need to know the definitions for these terms as well as some examples or scenarios. The first term is an agonist or the prime mover. And a muscle that is considered a prime mover is really responsible for a specific movement, like knee extension or elbow flexion. Whatever opposes the prime mover or the agonist is known as the antagonist. This is the muscle that undoes what the agonist does. 2 more terms that we need to consider when looking at groups of muscles. The first is a synergist, and we will see this throughout the entirety of Chapter 10. There are many muscles that help with actions. While their main responsibility is not that action, they do contribute. We also have fixators throughout the body. And these are going to be muscles that are considered synergists, but they really help to stabilize or fixate a bone or that muscle's origin. The next couple of slides will help to continue to lay the groundwork before we begin to learn muscles. Now, as we move throughout this lecture and this chapter, remind yourself of what an origin is and what an insertion is. As we learn muscles, in addition to origin and insertion, we will also bring in actions. When you are trying to identify an action, you need to identify first the action, but also either the joint that the action is occurring at or the body part that is involved in the action. On this slide, we are looking at flexion and extension, 2 actions that are opposite of each other, but they are related to the joint angle. Flexion will be a decrease in the angle at the joint or between 2 moving parts. Now, the muscle that they provide for you is the pectoralis major muscle on the anterior chest. Flexion at the shoulder is produced by the pectoralis major. So if you take your upper limb and put it out in front of you, that is flexion at the shoulder joint. Now the opposite of flexion is extension, when we have an increase at the angle of the joint or between 2 moving parts. The example that we have provided is the latissimus dorsi muscle found on the back, or the dorsal aspect of the trunk. Now, take your upper limb and move them posterior or behind you. That is extension at the shoulder joint. In addition to flexion and extension, 2 more actions that you will see more frequently will be abduction and adduction. These two movements will occur at the upper and lower limbs. Abduction, think of an alien abduction. You are taking away from. So abduction of the upper limbs will be moving your upper limbs out to the side, rather than in front of or behind you. We also see a deduction occurring at the upper and lower limbs. Think of starting with your lower limb kicked out to your side. Now add it back to the body or move it towards your midline. That is adduction. The examples that they have provided for you are the deltoid muscle for abduction and the teres major muscle for a deduction or adduction. Throughout parts 2, 3, and 4 of Chapter 10, you will see an extremely long list of muscle names. The first thing you shouldn't do is panic. You should see a name and try to break it apart and understand what it tells you about that muscle. When we name certain skeletal muscles, we use these key factors like the location of the muscle, or the muscle shape, or even the size. When looking at the muscle location, sometimes muscles are named based on the body region that they are in. For example, there is a muscle known as the temporalis muscle that is found on the temporal bone of the skull. We could also name a muscle based on its shape. For example, the deltoid muscle on your shoulder. Deltoid means triangle. This is a triangular shaped muscle. We will also see muscles named based on their size. For example, the gluteus maximus muscle. It is the largest of the 3 gluteal muscles. In addition to the location, the shape, and the size of the muscle, we can also use these factors when naming skeletal muscles, like the direction of the fibers or fascicle. We will see muscles like the rectus abdominis muscle, and that will be a straight muscle in the abdominal region of the body. Transversus means running in the transverse plane, like the transversus abdominis muscle. Sometimes muscles will be named based on the number of their attachments or origins. For example, the biceps brachii and the triceps brachii have 2 and 3 origins respectively. Another factor that we can use when naming skeletal muscles will be the location of the origins and/or insertions. For example, there is a muscle in the neck known as the sternocleidomastoid muscle. The name of the muscle literally tells you the 2 origins and the insertion. Lastly, we can name a muscle based on its action. You will see many extensors as well as flexors. Use the name of the muscle to help you figure out what it does, where it's located. For the most part, we will use different factors when naming skeletal muscles to create just one muscle. For example, extensor, carpi, radialis, longus muscle. That will be a muscle that first will extend the wrist, and it will be found on the radial side of the forearm, or the lateral side. And longus simply means long, as opposed to short. Something else that we need to address before moving into the actual muscles will be the arrangement of fascicles. If you remember from Chapter 9, a single fascicle includes many muscle fibers. A muscle as an organ, like the biceps brachii, contains many fascicles. But these fascicles or groups of fibers can be arranged differently, and we will see muscles with different shapes as well as different functional capacities. The 4/5 common patterns are listed on this slide. You need to know the definition or the arrangement of each, as well as be able to provide examples. We will see the following arrangements listed below: circular, convergent, parallel, pennate, and one that is not listed is fusiform. This slide provides you with the majority of the definitions for the fascicle arrangements, with the first being circular. As its name suggests, these fascicles are arranged in rings or in circles. We will see two muscles on the face that are found in a circular arrangement, one of them being the orbicularis oris muscle. Orbicularis means orbit, like circle. Oris means mouth. This muscle encircles the mouth. Next, we have convergent. So think about many fascicles converging or coming together for a single insertion. The best example is the pectoralis major muscle on the anterior chest. Next, parallel. The fascicles are parallel to the long axis of the muscle or to the body part that it is found on. The example that we have provided is the sartorius muscle. The sartorius muscle is found on the anterior thigh, overlying the quadriceps. Next, fusiform. So think of some muscles that will have 2 or potentially 3 origins. They are going to fuse those origins together for one insertion. This is not the same as convergent. An example would be biceps brachii in the anterior arm. On this slide, we have provided an image of each of the examples for you, with A being circular. Again, orbicularis oris encircles the mouth or the oral cavity. B, convergent, pectoralis major on the anterior chest. C, fusiform, the biceps brachii. You could also say triceps brachii. D, parallel. Again, sartorius is found on the anterior thigh, overlying the quadricep muscles. And the one arrangement that we haven't talked about yet is known as pennate. A pennate muscle, or the pennate fascicular arrangement, involves short fascicles or short groups of muscle fibers that attach to a central tendon, and they almost resemble a feather. We have 3 types of pennate muscle fascicular arrangements: unipennate, bipennate, and multipennate. The most common will be bi and multipennate muscles. Multipennate, the example that we have provided is the deltoid on the anterior shoulder or surrounding the shoulder. Bipennate, so 2 now, rectus femoris on the anterior thigh. And lastly, unipennate, so we have 1 row of fascicles attaching to the central tendon, extensor digitorum longus, in the leg. On the previous slide, you saw 3 examples of the pennate muscles. Again, a pennate fascicular arrangement includes short fascicles or short groups of muscle fibers that attach to a central tendon at an angle. The term oblique or obliquely means at an angle. We have 3 different forms: uni, bi, and multipennate. Again, please know an example of each of the 3 forms. We will finish up Chapter 10, Part 1 by looking at the 3 different types or 3 classes of lever systems. But first, you should understand that skeletal muscles produce movement. Skeletal muscles attach to bones and skin. And when they pull on the bones and skin, they're using leverage to produce their movements. When looking at lever systems, there are 3 components. Each class of a lever will have a different arrangement of these following components. There's the fulcrum, or the joint, which is what we move around. It's a fixed point. Next is the effort, and that's going to be the force that is produced by muscle contraction to move the last component, known as the load. The load includes the resistance that is being moved. This includes the bone, as well as the tissues and any added weight, such as a dumbbell or a textbook. We will now look at the three classes of. A second class lever is where we find the load now in between the fulcrum, or the fixed point, and the effort. A great example is a wheelbarrow. The wheel will be the fulcrum. The barrow portion contains the load, and the effort is placed on the bars where you lift it. And lastly, the third class lever is the most common type of lever found in the muscular system. The effort is being applied now between the fulcrum, or the fixed point, and the load. Other examples in addition to skeletal muscle include tweezers or forceps. This slide demonstrates the three classes of lever systems as well as examples of each. Again, a first-class lever, we find the fulcrum in between the load and the effort. The primary examples given were scissors or a seesaw. Second-class lever, now we find the load in between the other two components, the fulcrum and the effort. We saw a wheelbarrow as a good example. And lastly, the lever system most commonly used by skeletal muscles is a third-class lever. This is where we find the effort now in between the fulcrum and the load. Now, even though the effort is the biceps brachii, that effort is being applied to the radial tuberosity on the radius, which is actually in between the elbow joint and the hand where we find the dumbbell. Again, this was Chapter 10, Part 1. We introduced terms related to functional groups of muscle. We reviewed certain actions that we will see here in the future. We talked about naming skeletal muscle and the criteria that we can use. We finished up with the fascicular arrangement of muscles and lever systems.